Hello students, this is chapter 2, class 9, chemistry. The name of the chapter is matter around us pure? Students, we've been studying about the matter right from our lower classes. Let's briefly review what we have studied about matter in our lower classes. Matter. Anything that has mass and occupies space is called matter. Matter can be classified into different types on the basis of their properties. Like on the basis of the states, the matter can be classified as a solid, liquid, or gaseous. We studied these things in our lower classes. In this chapter, we will see the classification of a matter on the basis of the purity, on the basis of their purity, whether the matter is pure or impure. So here you can see the flow chart showing the classification of a matter based on their purity. So matter is classified as a pure substance and impure substance. Impure substance is also called a mixture. Pure substance can be further classified into elements and compounds. Impure substance, which is also called a mixture, can be classified as a homogeneous mixture and heterogeneous mixture. Homogeneous mixture is also called a solution. Heterogeneous mixture further can be classified as a colloids and suspension. We'll discuss about the classification of this impure substance as a homogeneous and heterogeneous after a short while. Let's briefly discuss about this pure substance, elements and compounds. Students, what is elements and what is compounds? Elements are those pure substances which are made up of only one type of particles. Now, when I say particles, in chemistry, we have a different type of particles like atoms, molecules. We have many more. We will discuss more about these particles in our coming chapters. Elements are those pure substances which are made up of only one type of particles. Either it is atom or molecules. Now compounds, what about the compounds? Compounds are those pure substances which are made up of only one type of molecules. Now what is atoms and what is molecules? Students, atoms are the smallest particle of a matter which cannot be further subdivided into smaller particles. We all know about the atoms. Atoms are the smallest particle of a matter. Even molecule is also the smallest particle of a matter. Then what's the difference between the two? We'll discuss about the difference between the atoms and molecules in due course of a time. See, these elements further can be classified into metals and non-metals. These are the metals. These are some of the familiar metals. We all are very much familiar with these metals. Aluminium, iron, sodium, potassium, sulfur, and many more. All these elements are metals. These are made up of only one type of particles and they are atoms. So aluminium is made up of only one type of particle, aluminium. You think about the strip of aluminium. You take one strip of aluminium and this aluminium strip will be made up of uncountable number of aluminium atoms. The same here in case of iron. If you take a strip of iron, this iron strip will be made up of infinite and uncountable number of iron atoms. The same is with sodium. If you take a piece of sodium, the sodium piece will be made up of infinite and uncountable number of sodium atoms. Now non-metals. Students, we know about the non-metals. Non-metal exist in all the three states: solid, liquid, and gaseous. Solid non-metals. If I write the example of a solid non-metals, carbon is a solid non-metal, sulfur is a solid non-metal, phosphorus is a solid non-metals. Now this non-metals, solid non-metals, these are made up of atoms. But this gaseous non-metals, they are made up of molecules. I'll distinguish between these atoms and molecules in due course of a time, students. For the time being, you just remember non-metal exists in all the three states: solid, liquid, and gases. Solid non-metals like carbon, sulfur, and phosphorus, these are made up of atoms. But gaseous non-metals like hydrogen, nitrogen, oxygen, fluorine, these all are made up of molecules, the smallest particle of a matter. Compounds. Compounds, as I mentioned, compounds are those pure substances which are made up of only one type of a particles, that is molecules. Now, water is a compound. Water is made up of particles. What is the name of that particles? The name of the particle is molecule. So water is a compound which is made up of infinite number of, uncountable number of water molecule. If you take a glass of water, if we could see the small particles, then we would have seen infinite number of water particles moving randomly throughout the glass. So water is a compound which is made up of particle called molecules. So water molecules. We have a glass. Think of a glass. Now this glass is full of water. This glass consists of water molecules. Infinite number of water molecules will be there. So these small particles of which this compound water is made of, that's water molecules. Similarly, carbon dioxide is a compound. If we have a container, if we have a cylinder filled with carbon dioxide, that cylinder will consist of a carbon dioxide particles called carbon dioxide molecules. Infinite, uncountable number of carbon dioxide molecules. Similarly, if I take a gas-filled container, a container filled with ammonia gas. Students, this ammonia, this is ammonia, NH3 stand. This is the chemical formula for ammonia. Remember this. Ammonia. If we take a cylinder filled with ammonia, that cylinder consists of infinite, uncountable number of particles. That is ammonia particles, NH3. Elements. Elements cannot be split by physical or chemical methods. If I take a strip of aluminium, if I try and divide, if I go on dividing that strip of aluminium, ultimately a stage will be reached where we will get the smallest particle of that metal aluminium. We cannot further divide that small particles into sub particles. So that small particles is the atom. So metals cannot be subdivided into further smaller particles than atoms. But in case of a compounds, the compounds can be further subdivided into particles. Example, let's take this water. Water is a compound. Now if I divide this water, I'll get the particles of pure substance, hydrogen and oxygen. So that's what I mean by dividing into smaller particles. But if I take a aluminium particles or aluminium metals or iron metals or sodium metals, potassium, this cannot be further subdivided. The small particles of these metals are atom. Smaller particles than atom doesn't exist. So we cannot get smaller particles than atom in this case of a metals. But in case of a compounds, you can see compounds are made up of hydrogen and oxygen atoms. So if I split this compound, I'll get the particles of hydrogen and oxygen. If I split this compound, I'll get the particle of a carbon dioxide, carbon and oxygen. If I split this compound, I'll get the particles of a nitrogen and hydrogen. That's what I mean when I say a compound can be further subdivided into smaller particles. So I hope students you understood about the difference between elements and compounds. Now let's move on to our impure substances. As I mentioned, impure substance is also called a mixture. We have two different types of impure substance. One is homogeneous mixture, another one is heterogeneous mixture. Homogeneous mixture is also known as a solution. And heterogeneous mixture further can be classified as colloids and suspension. Before we understand or before we differentiate between the colloids and suspension, students, let's understand about the homogeneous and heterogeneous mixture. Students, we make a number of mixtures in our daily life. Take the very simple example of sugar or salt mixed in a water. That's a mixture. Now, if I dissolve a pinch of a sugar into water, I'll get a mixture. So now that mixture will be a solution or a colloid or suspension. That mixture will be homogeneous or heterogeneous. How to identify this? So homogeneous mixture and heterogeneous, first point of difference between these two is uniform composition. In case of a homogeneous mixture, we get the uniform composition. Heterogeneous mixtures, it's a variable composition. Now when I say uniform composition, what does it mean? Variable composition, what does it mean? Now think of a sugar water mixture. If we take a teaspoonful of a sugar water mixture, say suppose we have a glass containing sugar water mixture. This is the sugar water mixture. If I take a teaspoonful of sugar from this part of this container and taste it, and if I take a small teaspoonful of this sugar water mixture from this part of the mixture, and if I taste, this two part of the mixture tastes the same. If you take a teaspoonful of sugar water mixture from this, it will not taste different than this part. Whether you take the teaspoonful of a sugar water mixture from this part or this part or anywhere, it will taste the same. That's what I mean by uniform composition. Uniform composition means the sugar, what you have dissolved in this container containing water, the sugar has distributed uniformly, equally throughout the body of this mixture, throughout the body of the water. That's what I mean by uniform composition. Variable composition means what? Now say suppose if I take a handful of chalk powder and if I throw, say suppose this is the plate, I have a sand here. Let's say suppose this is sand. If I take handful of soil and or chalk powder, let's say, if I throw that chalk powder into this plate containing a sand, what do you think? That sand or this chalk powder, what you have taken, what you have thrown into this container, do you think that sand will be distributed equally? No. If you look close, if you observe close, some part of this container, the chalk distribution may be more. Some other part of this container, this plate, the chalk distribution may be less. And some part, you may see the chalk distribution is absent. What I'm trying to say is, when you throw this chalk powder here, the chalk powder will not be distributed equally. That's what I mean by uniform and non-uniform composition. This is the example of a non-uniform composition. And the distribution of a sugar throughout the body of a water is a uniform composition. That means sugar is distributed uniformly, equally throughout the body of a water. So that makes the uniform composition. But mixing of a chalk powder into sand, this is non-uniform composition because the chalk powder will not distributed equally throughout the sand. So it's a variable composition. I hope, student, you understood what is the meaning of uniform composition and non-uniform composition. So if you have a mixture where the composition is uniform, that type of mixture is called a homogeneous mixture. So our sugar water mixture is a homogeneous mixture, and sugar water mixture which is a homogeneous mixture is also called a solution. That's why we say sugar water solution. So sand or chalk powder thrown into sand, because the chalk is not distributed uniformly throughout the sand, so it has a variable composition. So that kind of a mixture is called a heterogeneous mixture. Now, second point that distinguishes this homogeneous and heterogeneous mixture is the components of the mixture cannot be separated by visible boundaries. Now, what is the meaning of this? Students, when you take a pinch of a sugar and if you dissolve that sugar into this container containing water, the sugar is distributed throughout the water uniformly, equally. And when I see through these solutions, it appears to us that it's uniform, it's one. There is no other components. It's not possible for us to distinguish the sugar particle or the water particle. It looks same. That's what I mean by cannot be separated by visible boundaries. We cannot see the boundaries. We cannot see the boundaries distinguishing sugar particles and water particles. That's the identity, that's the nature of homogeneous mixture. But here in this case, where you have thrown chalk powder into sand, you can easily see the boundaries separating the chalk particles and the sands. That's the nature of a heterogeneous mixture. Now, students, heterogeneous mixture can further be classified into colloids and suspension. Let's understand what is this difference between solution, colloids, and suspension. So, first point of difference we all understood: solution is a homogeneous mixture, colloids and suspension are heterogeneous mixture. Okay, students, let's see. Here is a table showing the difference between solution, colloids, and suspension. Solution is a homogeneous mixture, colloids and suspension are heterogeneous mixture. Solutions. Student, let's take the example of that sugar-water mixture, sugar-water solution. Now, sugar particles in this homogeneous mixture, if we consider the particle size, the sugar particle size ranges, or we can say the particle size is smaller than nanometer. This 1 nm stands for nanometer. So 1 nanometer is equal to 10 raised to power minus 9 meter. Remember this. The particle size is so small that's not possible for us to see even with the powerful microscope. Students, to get the feel of this nanometer, let me give one example. We all know 1 meter scale. If we could divide this 1 meter scale into 10 raised to power 9 parts. Now think about this number. 10 raised to power 9 parts means 1 followed by 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So using number system, if you count this number, 1 tens, 100, 1000, 10,000, lakhs, 10 lakhs, crore. It's 100 crore. Students, if you have a 1 meter, imagine you have 1 meter scale. If we could divide this 1 meter scale into 100 crore parts equally, if we could divide this 1 meter scale into 100 crore parts, that one part would have been the size of a 1 nanometer. So 1 nanometer is that small. So the particles, sugar particles in solution, or the particle size in solution, is less than 1 nanometer. So 1 nanometer equals 10 raised to power minus 9 meter. Now, coming to the colloids, heterogeneous mixture, the particle size is more than 1 nanometer and less than 100 nanometer. Particle size range in the range of 1 nanometer and 100 nanometer. So in case of a colloids, the particle size is more than 1 nanometer but less than 100 nanometer. In case of a suspension, the particle size is more than 100 nanometer. Because the particles are more than 100 nanometer, in this case, in the case of a suspension, we can see the particle size even with a naked eye. Now think about clay water. If you take a glass of a clay water, you can see the particles of a clay water. Or take the example of a chalk water dissolved in chalk particles dissolved in water. So chalk particles easily we can see. So that's the example of a suspension. Students, one more point is there that distinguishes this homogeneous and heterogeneous mixture, solution, colloids, and suspension. That's a Tyndall effect. Now, what is this Tyndall effect? Tyndall is the name of a scientist. So he observed this phenomena. That's why this phenomena is named in his honor. So it's a Tyndall effect. Let's understand what is this Tyndall effect. Students, suppose you have a solution. You have a solution here. Let's say you have a sugar water solution. This is sugar water solution. Sugar water solution. If I pass the light through this sugar water solution, I can see the light passing on the other side, but we cannot see the light inside the solution. We cannot see the light inside the solution. The reason is the particle size being very small, they're not able to scatter the light. So this is what we mean by Tyndall effect. Here the particle size, the solute particles, the particles in solutions cannot scatter the light. That means the solutions do not show the Tyndall effect. Here in case of a colloids, let's understand. You have a suppose colloids. Now colloids example, there are many examples are there. Say suppose milk. Milk is a colloid. Soap solution is a colloid. Blood is a colloid. So many more examples are there, but these examples are very familiar to us. Suppose we have a milk, a colloid, or a soap solution. If I pass the light through this soap solution, we can see the light passing on the other side. We can also see the light inside this soap solution. The reason is the particle size is bigger than the particles of solutions. So because the particles are bigger in size, they can scatter the light, so we can see the light inside the solution. That means the colloidal solutions, or we can say the colloids, scatters the light, or we can say colloids shows the Tyndall effect. Of course, our particles are bigger in case of a suspension, so definitely if I pass the light, we can see the light inside this solution. That means suspension also shows the Tyndall effect. Students, this Tyndall effect is the only one property that can distinguish the solutions and colloids. Solutions and colloids, of course, solution is a homogeneous mixture, colloids are a heterogeneous mixture. But solutions and colloids have a property so similar that it appears colloids as a solution. So that's why sometimes we say colloid as a colloidal solution. So to distinguish solutions and colloids, we can use one property, that's the Tyndall effect. So solutions do not show the Tyndall effect, but our colloidal solution shows the Tyndall effect. So that's how we can distinguish solutions and colloidal solution. One more point is that distinguishes these three. Solutions cannot be separated by filtration process. The particles of the solutions cannot be separated by filtration process because the particles are very, very small. If you take these solutions and if you pour this into filter paper, the particles will pass through the filter paper. If you take this colloidal solutions, if you pour this colloidal solution into filter paper, this colloidal solution will also pass through the filter paper. That means the solution particles and the colloidal solution particles cannot be separated by the filtration process. But in case of a suspension, the particles being very bigger in size, if you pour this suspension into a filter paper, we can separate the particles of a suspension. So these are the points distinguishing solutions, colloids, and suspension. I hope student you understood this. So that's all.